Gryleski. I'm a senior developer advocate at DataStax, the company that makes, well, they don't make Cassandra. Cassandra is Apache Cassandra, but there's a managed cloud platform called Astra DB, so that's a DataStax product. But otherwise, too, DataStax is very much an open source kind of focused company. There's a Cassandra, then there's also Apache Pulsar, of which I got hired to like 2.5 months ago. So I'm fairly new to Pulsar. Okay, so, and I was working for IBM previously for their Java advocacy for like 3.5 years before this. So, and I'm a Java champion and also a very passionate developer advocate. I travel, I do outreach, and then during the COVID times, I was doing mostly online, pretty much all online presentations then. And I also have my own Twitch stream as well that I will share with you towards the end of this presentation too. I'm also an active community organizer and builder, so I'm the president of the Java users group in Chicago, and that's where I'm based at, in Chicago. So, okay, and then I have worked with Java. Actually, before becoming an advocate, I was a developer, software engineer like yourselves, maybe many of you here, for about 20 years in Java alone, and all kinds of things, not just like focus on one thing, but as such, it just kind of have different kind of things within Java, the ecosystem. But primarily, I was doing the enterprise edition kind of work, EE work. So as you can see over here at IBM, actually, I help out with Open Liberty, which is the WebSphere open source edition, Jakarta EE, all of these, micro-profile, and also reactive systems, too. That's what I've been doing as well. So that's a bit of me, and my interest is in distributed systems. I've worked a bit, too, with IoT, MQTT as well, just immediately prior to this. So, okay, so that's about myself. Okay, so today's agenda. So I'm just going to start talking about why CDC. It's essentially to serve databases, data lakes, any kind of like data source, detecting the changes like that. And what was there before CDC? It's basically ETL. And ETL is, I can't remember, what is it? Transformation and load, what is it? Extract, transform, and load. Sometimes I just can't remember the words. So talking about ETL and then some drawbacks, and that's why like CDC is this pattern to detect changes in the state of data. And then I'll talk about the components of a CDC system, and then also the requirements for modern day CDC system in today's cloud-native world. And then I will then introduce to you Apache Pulsar, and then give you a quick demo, and specific to DataStax product, the Astra streaming too. So that's the agenda for today. I think I have about 45 minutes or so. Okay, so first of all, like why data capture? And so what is CDC for? So basically, as such, right, the fact that the pattern has the word data, it means it's basically to serve data sources. So data sources will be like, most commonly will be databases. All kinds of databases, data source, all kinds. So there are always changes that is happening all the time, as we know. So we need to have a way of detecting it and capturing it, and then also not only detecting, having the data, but you want to capture it, and then propagating the changes in data sources to downstream data systems. So that's essentially what it is. So as such too, maybe some of you are also working with data warehouse, more of the database analytics, right? Can I kind of see a show of hands, how many of you are also working with data warehouse and data mining things? Have you? Are you working with that? Okay, no problem. So like data lakes and data warehouses too, that's also kind of very useful for those type of application and doing analytic kind of work too. So a bit of a simplified illustration of CDC. So you see that there's a data source, and then basically the CDC in the middle is like detecting changes. So any kind of changes you are observing too. There are a lot of things that in today's world too, we're using event-driven type of systems that will be detecting changes. You're doing some inspection. So whenever there's changes, it will get it, capture it, and then transform it. And then basically, sometimes you need to transform the data. Sometimes maybe it's a pass-through that essentially too, you want to transport the data down to another target, downstream data system. So that's kind of essentially like a quick illustration of what CDC pattern is. Okay, so, actually I forgot to, yeah, that's why there's detect changes, and then capture, right? Capture any kind of, if there are changes, you capture it from the data source, and then you transform the data. Sometimes, transformation may not happen every time, but essentially that's what you can have to do transformation. And then basically you then propagate those changes to downstream system. So, okay, so now then what was there before CDC? So before CDC, actually the extract, transform, load. So if you're working with database, then you probably may be familiar with it. And a lot of times too, I think it tends to be, if you do databases, you have a lot of ETL load, kind of ETL data loading kind of activity going on. And most likely too, you are doing that at off hours, kind of in batch, big quantity. So the disadvantage too, I mean, the thing is, don't get me wrong, right? It works, this kind of ETL processing, I believe is still very much, kind of a big part of any big, especially big corporation. You have data that, during the day, like, that does many things, right? If you are trading firms, especially, right, there are plenty of trading activities going on. You need to capture all of these data, and then it needs to be processed at some point in time. The thing is that you don't want to do this type of work during the day because it's huge amount of data. Also, then you will take away computing power from your real-time existing systems that are serving things in real time. So you want to do it probably off hours at nighttime and doing like data in bulk. However, if you think of it like this, then it's basically the data that you have detected for changes you won't see it until perhaps the next day after it's been processed, like at nighttime. The thing is that with this approach is good, but the thing is it's slow, and it's a very synchronous way of doing things. Like essentially, you take all the data offline, process it, and any changes you don't know until the next day. And I actually have to also mention something while I'm here, kind of all of a sudden occurred to me. I arrived at the airport yesterday in Istanbul, and then I was trying to, Nursel, who's so nice, right, the organizer here, sent all of us speakers like a guide of how to get the shuttle bus from the airport to here. So I said, okay, wonderful. And then actually she sent it over Slack. We have a Slack channel. And then I said, great. I was trying to open that document, but I think because of the connection, I was having my cellular network from the US, and so only getting 2G, very slow. So I said, okay, let me connect to my Wi-Fi. However, the Wi-Fi too then is asking me, okay, you need either go into a kiosk to get the SMS code or do a mobile login. And then I have my mobile phone, so I said, okay, cool, let me do mobile login because I couldn't find any kiosk. And then I enter my, I connect first to the SSID to the network, the Wi-Fi, and then the endpoint. And then it says, okay, I'm going to send you the code, and gives you 2 minutes to log in with this code. But the fact is, I think there's some latency there because then I think it's my network. It needs to send this request to my cell phone network and all this. And so it comes back the code. It's always past the 2 minutes limit. So I never got connected to to my the Wi-Fi. So I said, well, what to do, and I couldn't read, right? There wasn't as much English translation. I knew there were buses, so I was like, which one? Anyway, so I kind of text Nursel again, and fortunately on my cell network I could do my Slack, and then she said, well, just ask around. And then I said, okay, I still was trying to get my mobile login, but still it didn't happen. So the point is, well, eventually Nursel did say ask around, and then I asked the guy at the info desk, but then he was like, okay, well, you going? I said I go to Hilton. And then he was like, okay, take the Texim. And then I said, Texim. I said, okay, all right. I found number 16 bus, yeah. And then I realized, oh, wait, I think the name of the stop should be it starts with a Y, which is Yeni Saba over here. And anyway, so fortunately, I kind of asked this question to the bus driver right before I boarded the bus, and he said, no, the Hilton, the other one is on the number 14 bus, so that's what I did. So eventually made it, but as you can see, it took quite some time. So the point of telling that story was that because I was waiting for the mobile login, and there's all these latency in there. So I think immediately too, I was thinking that might be a good example of what I'm going to introduce to you using change data capture, kind of event-driven type of approach. I should be able to get the code right away and within the 2 minutes, so then I can log in. Otherwise, like myself, I did not have access to anything, and it's kind of a bit of a kind of a challenge at that point. So that was just some story to share with you. So anyway, let me go back to the ETL. So again, like ETL, right, processes tend to be very heavy. All these changes you're detecting, right? And you're doing it at night because then you won't, take up as much network bandwidth because a huge amounts of data needs to flow through. At the same time, right, think of it like that, in large sets of data. So as such too, ETL tools too also can be quite expensive. A lot of times, I think if you think of tools like from IBM, from Oracle, from all of these big companies are making ETL tools, they are corporate, you need licenses, it's pretty expensive. And then essentially too, they still work and everything. It's kind of good for maybe system of record type of changes. If you have employee changes, information changes, you might want to do the load at night and kind of not taking away computing power during the day. So anyway, that's enough on the ETL. So that's kind of before CDC. So essentially too, then change data system gets kind of, this concept gets introduced. And so what make up a CDC system essentially is the change detection. You have the detection kind of component, and then the capturing piece, and then also then the propagation part too. And of course, in between too is supposedly also a bit of a transformation that may be needed. You can also be in there as well. So just a note too about log-based CDC. So log-based essentially too, as you can see, right, these days if we're doing database kind of transaction type of scenario, we're doing like update table and then set, change some data, like update table, set, X equals 1 or something, and then, where maybe, the row is row ID or some kind of ID equals 1, 2, 3, something like that, right? Dynamically, you want to check that and to do the update. And so you see that there's like a transaction log, and it can be a many too. So this is an example too of a log-based CDC. So if you do like a set, set X and set 2, X equals 1, X equals 2, essentially too, you can only have one state of that column at that point, any point in time. So as you can see, you apply the CDC, this kind of keeps a whole transaction log, and then you apply the changes to propagate the changes to the downstream system, to the target data system, and essentially to the state, you can only have one at the end at any point in time. So in this case, you set X equals 1 first, then set X equals 2 next, then following. Then what you get in the target data system, the current state would be X equals 2. So that's just an example of like doing CDC like in a log-based kind of manner. So then let's talk about, we already touched on some older way of doing things. Then requirements for a modern CDC system, what would it be for? But first of all, let's kind of think of what a modern system is. So in today's world, we're talking about cloud native type of work, right? We need doing work in deploying your systems in cloud systems that are much more complex. It's clustering. You have replicated data, in a cluster kind of systems, and Kubernetes. It's probably first comes to mind. How many of you are already like working with systems that at work that's already deployed to Kubernetes, for example? Yeah, I think it's quite a few. But I understand too, there are also still systems that are maybe on the older style. You're still doing enterprise system. You're doing maybe like WebLogic, JBoss, and WebSphere, right? And am I correct? Yeah. So in that, so the thing is, right now, too, there's a lot of transformation going on into cloud native. Maybe we've heard more about it than actually doing something. But the fact is, we do need to be prepared, right, for more of the cloud native way of doing things. So essentially, too, just want to bring this up to you. Cloud native, there's also a 12-factor guidelines of principle of when you develop cloud native systems, what they need to be. So actually, I didn't actually have this. Yeah, I should have had this. But anyway, then if you go to a website called 12factor.net, it will give you a list of all of the requirements for like modern data systems. So essentially, too, I want to highlight is that modern systems, we want it to be very responsive. Like all of your data changes that happens, And all of the changes needs to happen like recognized dynamically. It's fast. You have to be very responsive. Previously, I was talking more about reactive systems, for example, and that helps with being like enabling your system to become more reactive, more responsive. So meaning that your request comes, you want to handle it right away, and then gives you the response very fast, without too much wait time. So that's the idea in a modern day. As you can see, right, we all have like cell phones and all of these, and especially with cell phones, we can leverage on like IoT or IoT protocols, such as like MQTT, things like that. So you want things to be really fast, and then it comes into play is maybe using a publish, subscribe type of system, pops up messaging kind of systems that can scale very fast. So another requirement of the modern system is scalability. So if you have more requests coming in, then you want the system to be able to respond back also quickly, and it scales it. In a cloud-native environment, you can spin up additional nodes to handle all of your requests. And as such, too, it's not as simple as just spin up some nodes. You need to kind of have a way of rebalancing all of your topic partitions, for example, right? Things like that. You need to rebalance if you have more workers. I mean, think of the fact that, right, we are in a big conference and we have a lot of people helping. If you add more people, it may not always work. You need to have someone to manage it. Okay, somebody coming in to do work, you need to balance it so then, this person is overloaded, you want to move some work to another helper, things like that. So same idea, right? The scalability is important, but you also have to have good way of managing it too. So that's kind of help with modern system. And then another aspect then would be like about resiliency, like recoverability. So if some parts of your system kind of doesn't work, die or something, you want to immediately, let's say in Kubernetes, you want to spin up another node, and Kubernetes takes care of things like that, right? And so you spin up another node, and again, if you introduce a new worker into the pool, then you want that to be very easily kind of get, spun up, and then do the work too. And also, it makes sure that your system is very recoverable. So if something happens, it doesn't suffer, the overall responsiveness doesn't suffer. So that's the idea of a cloud-native kind of modern system. Okay, so now that it comes back a bit to then talking about the change data capture, and then I wanted to bring up to about transmission of the data as messages, right? So I want to slowly then bring in that messaging systems. I know that a lot of times, I think even when I started as software engineer, we always, when we deal with data, we have some databases and then we rely on database and doing all these update, insert, all of these things. You're relying on database to do all of these things. But in the new age too, we want to rely on more of a messaging kind of approach to doing things. So I want to talk about transmission of data going from one state to the other as messages. So, and basically too, if you do work, you work with messaging systems, we want to guarantee reliability and resiliency. So reliability will involve, like, for example, like quality of services. Maybe some of you are working with messaging systems, maybe? Yeah, okay, so you're aware of QoS. So those are kind of mechanism that guarantees, because messages get sent, and then you want to guarantee, because it's asynchronous, so otherwise there wouldn't be any way of tracking. You can send messages and it never arrives at the destination. So you need to have a good messaging system will need to have QoS to guarantee, right? This kind of built-in. So if the network goes away or your broker goes away, something, right? You can't rely on any piece of it. That make sure that the data gets sent, is stored somewhere, and will be redelivered when it's back up, or you have another component come back in. The messages will be taken care of. So that's the important point, right? And so it guarantees delivery. And also then again about messages being very responsive, then you want to use an approach that's asynchronous, very lightweight. You want to essentially decoupled. You don't want to have two components are sending messages to have to know each other, so to speak, right? And you want them to be loosely coupled. There's the publish, for example, publish subscribe model would kind of serve that, right? Very responsive. You're sending out messages, and it's up to whoever is interested in the messages. You want to subscribe to the messages through, topic, for example, topic or a channel name, right? To kind of identify your messages, and you rely on a broker to do that, and that helps with scalability and decoupling of the sender and the receiver. And then I already talked about scalability. Using a pub/sub approach too, it helps with scalability, because if you have more requests coming in, you actually can spin up more brokers to handle all of these messages too. And just a word too about brokers, right? Just in case if you're not familiar, broker is there to help with delivery and receiving of messages. So you have publisher and subscriber, and basically publisher, we treat it like a post office agent, right? You want the publisher wants to send some messages, you send it, and basically you don't want to deal with it, so then you ask someone to do it, and that's the broker. So post office, you go there, you said, okay, I have some messages to send out, and then you label your messages as some topic, some channel name, and then it's up to the broker to deliver it to whoever is interested. And whoever is interested would need to subscribe to the channel, and then to be able to receive messages when the messages arrive. So that helps with scalability. And then another point about messages too is important, is not only with guaranteed delivery, but also the ordering too. So when it comes and when it gets sent, you want to maintain the message in order too, because certain data is important. You do need to keep things in order as it is being sent, and also when it arrives too. So that's kind of a few points to think of when we are doing messaging systems. Okay, so all of these, right, will essentially require a paradigm shift, right? And especially, even for myself, I started writing code more as synchronous manner, right? All of us started writing code, I believe. We're talking about sending a request. We make a request, and then we wait. We wait, and you don't do anything, twirling your thumbs and waiting for the response to come back, essentially, right? So now, with this new approach, we want things to happen faster. Then how about we take the event-driven approach? So now then I would like to introduce Pulsar. So what is Pulsar? So it is an Apache project. So it's open source. And basically the Pulsar was created by Yahoo in about 2014 or so, something like that. They were actually using Kafka at first to do the work. And then they quickly realized that it doesn't handle things. For example, if you need to scale up and you need to rebalance all of your topics, right? They get in a cloud setting. You can have topics that are being managed in different nodes, for example. So you have to plan ahead of time in Kafka, how many topics you need, right? And all these partitions, all of these things, it takes time to plan. But the thing is too, what about, we have a system that actually already has built-in capability of handling this type of growth. You need to grow your system, it gets bigger. All of the topics will get rebalanced accordingly in different nodes, right? Like I talk about if a conference like this, we need more helper. It does automatic rebalancing. That's the kind of one of the goals, right, of Pulsar. So anyway, so that's created by Pulsar, or created by Yahoo, and then they donated it in 2016 to the Apache Software Foundation, and quickly in 2018 it has become a top-level project. And essentially, too, if you think of it like that, I was just at Spring I/O, and then there was somebody that asked the question that was kind of cute. He said, would you call Pulsar is like Kafka on steroid, right? So kind of make it more powerful. I wouldn't call it on steroid. I think it's sort of a natural progression of any kind of messaging systems, especially I think in a cloud native world now. I think it's more like Pulsar extends what Kafka wasn't intended to do, because Kafka was designed before, before cloud native became more prevalent, so to speak. And Pulsar actually got the design after Kafka. So Kafka's design is more like, okay, I need to do all the compute, sending all the messages. I also need to manage all of the logs, right, the distributed log files and everything. So Kafka will do it themselves. So everything is sort of tightly coupled too. But Pulsar comes in and saying that, well, we need to have better ways of handling both the computing side and also the logging, distributed logging, management, the storage. There's a lot of messages too that get sent. So Pulsar was already designed, I call it like it was born with the cloud native DNA, because it kind of takes into account there's the cloud native kind of way of doing things. You're living, your components, all of these things are living in clusters. You need to handle tenants, right? There are different tenants. Think of it like a big building. You need to have different rooms that are individually being able to manage and things like that. So all of these kind of concept of the tenancy. So there's multi-tenancy already built into Pulsar. And it's pretty flexible. So then you don't have to so much worrying, when you set up a Pulsar, all of these things, you don't necessarily have to worry about planning your topics, all of these things, because by default, it already sets up all of the configuration for you accordingly. If your system grows, then maybe you have to do a little bit more replanning. But again, Pulsar already has this built-in capability of managing all of these nodes and all of these things in there. So it's more flexible, multi-tenancy, right? And also to interact with it too, there are simple client APIs to primarily it was written in Java first. It's still in Java. So you have Java client, pretty natural way to use Java client. But if you are a C# developer, you can also write C# to interact with it, Python and Go, and there's also community contributors. For example, like Scala, if you're a Scala developer, there's also Scala client that you can do, and other flavors too of clients. Again, I mentioned about it separates out the compute and the storage parts. So that's essentially how Pulsar is. And then again, it being a message kind of broker too, it has that capability. It guarantees your message delivery. So it's basically, you don't have to worry so much that the data would be lost. Pulsar already has this built in. And then it's also too, if you think of, okay, there are data that comes in, and I want to kind of make some transformation. In Pulsar too, there's a component is called Pulsar function. So it's kind of much like AWS also has serverless, or other libraries and framework also have functions. So you can do it functional way that you can write serverless functions too that kind of plug into your whole flow of things. So that's Pulsar function. And you can, again, write it in Java, C#, any languages that we support. And essentially, it helps with building out your data pipeline. And then another feature, too, of Pulsar, there are many other features, but I'm highlighting it here, right? And if you are dealing with having had to move data when it's aging out, then you need to, as developers, sometimes we have to worry about it too, right? The data is getting old, it's been stored too long in here, and we want to move it to offline storage, right? From hot to cold storage long term. The thing is with Pulsar too, also it has this built-in capability that you don't necessarily have to worry so much about the tediousness, right, of dealing with moving data, all of these things. You can kind of configure it, and Pulsar will take care of things for you. So these are just some of the highlights of Pulsar that you can use for. So, and then this is another slide just showing you what is Pulsar. So over here, wanting to point out that it's not just some, capability from outer space. It is actually getting to be quite popular these days. Just wanting to show you a couple slides or graphs too on the far right side. And it's showing you that the number of committers and people joining the project has been growing since the beginning days, or when it became an ASF project. So, as you can see, it's growing. And even I think in last year, a year ago, the number of contributors actually surpassed that of Kafka too. So that's, I just thought I can share with you too. So if you are interested in joining, everybody's welcome to kind of join and help with the project. Okay, and then you may wonder too, who else is using Pulsar? So these are companies, Yahoo being the first and foremost, and in fact Yahoo finances all of these specific services are all using Pulsar. And then there are also other big companies like Verizon in the US, there's a cell phone company, Splunk, and then a couple companies in Asia too, in China predominantly, also using it. And there's increasing number of companies, financial, all kinds, that are considering using Pulsar. Okay, and this is just history. I already talked about it, so I won't kind of go too much about it. But just wanted to point out too, last year, December 2021, when we had the problem with the Log4j kind of vulnerability problem, that gets patched right away. So just to kind of give you an idea. Okay, so a bit of the components of Pulsar too. As you can see earlier, I talked about CDC, right? The data capture, detection, and then basically detector, capture, and then take it, and then send it, propagate it to downstream. It actually fits in very well using something like Pulsar because it helps with building out your data pipeline, and that's the goal. So these are like different components of Pulsar. Wanting to point out there's producer, and then the consumer, and broker that I already kind of explained is like a post office master that kind of manages all the messages, right, and disseminating it, receiving like that. And then interestingly, I want to point out is that with Pulsar, it doesn't handle all of the logging, log storages. As you can see, right, messaging happens really fast, and it happens in many, right, it can be 100,000 or even more per second, right, and you can do that. And so all of these messages needs to be logged somewhere. And so Pulsar doesn't want to deal with it, so it essentially delegated, right, I call it delegate, to Apache Bookkeeper. So there's another Apache project called Bookkeeper, and Bookkeeper, that's its specialty, is to manage like large volumes of data, logging kind of data. So it kind of it coordinates, basically the broker kind of coordinates with the Bookkeeper, and Bookkeeper will manage all of these distributed logs, in huge quantity like that. So. And I won't get into details of Bookkeeper, but if you're interested, you can look up Apache Bookkeeper to get more details too if you're interested in that. And then there's also Zookeeper. So Zookeeper is kind of essentially help you to manage like complicated like clustering type of environment. It manages cluster metadata, handles coordination tasks between all of the Pulsar clusters. So it basically makes use of Zookeeper to help with that. Okay, and then really quick kind of introduction, another introductory is basically Pulsar. It is a tiered architecture design, and it is traditional multi-node architecture. So basically it supports a distributed architecture with support like horizontal scaling too. And then partitions topic abstraction, it masks all of the complexity from all of the consumers too. So you can basically also have topics that kind of get partitioned too. So it has that already built in. And when you kind of, I'll quickly show you too when I get to the demo part, how you can like leverage on, for example, a vendor. There are many vendors too, or many open source projects, but I work for DataStax, so there's actually, you can do Pulsar like streaming to using the managed Cassandra database. So I will show that to you in a little bit, and you can kind of see how you can create topics very easily. Can be persistent topic or non-persistent, can be partition or not partition too, so, okay. And then over here too, there's some common challenges too when you deal with software on this level, right? You need to scale, then you need the partition to get rebalanced across all of your nodes in your cluster, all of these things. And then there's also it tends to be, if the problems tends to be also like a tightly coupled kind of persistence and message serving capabilities too. It can be very expensive, right? Expensive in terms of if you need to scale it, it gets very hard to kind of continue, your processing. If you want to have persistent, or dealing with the log messages and dealing with the message serving part too. So all of these things too is basically Pulsar can ease all of these challenges for you. Okay. And okay, so this one I won't get into all the detail, but again, essentially want to highlight is the bookie too, the bookkeeper part. If you are kind of into that, right, there's the capability of doing ledgers, like you doing accounting, right, the ledgers and the journaling, all of these things are already handled by Pulsar too. Okay, and basically, let me kind of see the time. Okay, so just wanted to kind of summarize is that Pulsar has really solved the problem of bolt-on. So let's say if you're already running on-premise type of systems, you don't have the cloud yet, but you want to be able to start moving things to the cloud. Pulsar can actually help you without you making changes to your existing infrastructure. So you kind of think of it, this diagram is like you bolt on, you can put Pulsar on top of what you already have. You already have Kafka, no problem, keep it, right? You have JMS running or using RabbitMQ, all of these, you can basically bolt on and use Pulsar on top of it. So essentially, Pulsar offers you this unified solution. Oops. Okay, anyway, so it's a unified solution for doing PubSub and even queuing too. Now, how do you do queuing? I'll quickly kind of show you. When you set up Pulsar, basically, Okay, and basically you can have, well, you do publish, subscribe, but there are different modes of the subscription too. So one is called exclusive mode. So the exclusive mode is essentially enable you to do queuing too. So just a word about message queuing. So there's also difference between pub/sub, like event-driven messages. So queuing is basically you have a sender and receiver. They have to know each other. That's queuing. It's one-to-one kind of scenario versus like, you know, you doing pub/sub is one-to-many, but the queuing too. So if you want to do queuing in Pulsar, you can basically use the exclusive mode, and that will turn your messaging into like queuing kind of approach too. So. And basically, it helps too with streaming, right? Streaming is more like many events happening all at once, many publish, subscribe. So Pulsar helps you with that. And also with the message mediation and enrichment through the use of Pulsar function too. So basically, it's already poised for the cloud native kind of age that we are in. So it's multi-region support, and it also does what is called like geo-replication too. So if you're working for a big corporation, it's actually a good good framework to consider, you know, if you're working with that. So. Okay, so now enabling CDC, right? Enabling this for Astra DB. So I get a bit more into DataStax. So over here too, if you're working with database table with managed Cassandra, so you can basically enable the CDC, and basically too, as you can see, you can create like streaming tenant. There are data topics and log topics, all of these things, and also too, like you have all your data capture and everything. You can then send it to downstream to what is called a sink, right? It's like messaging system, a source and a sink. So we have this capability in there. Downstream targets, for example, you can send it back to another table within Astra DB, or send it to another database, just to some Java destination too, or to Kafka too. You can send it to a Kafka sink. And also another popular usage would be with Elasticsearch. You want to send it to an Elastic sink. So we also already have the connector built up in Pulsar. This is actually Pulsar. And the thing is too, with Pulsar, you can also leverage on a capability called Pulsar connector too. So the connector is like, if you want to, let's say, I got asked by people wanting to do Terracotta or something, some older thing, you can actually build your connector as a sink to receive the data as well. So it's really, really flexible is what I'm trying to explain. So, okay, so this is just DataStax and marketing. We're doing better. But the thing is that there's also another company you might have heard of, is Stream Native. They're actually the original Yahoo group of engineers who started the company called Stream Native. So they are all about Pulsar, that company. But we want to talk about it too, because this is Apache project. So, and okay, and then just want to kind of quickly point out to you for DataStax, we have Astra streaming, and I will quickly show you again how you can get access to the Astra DB. So it's managed database platform on Astra is Cassandra, and then there's Astra streaming capability that you can use too. And basically, if you want to have more capability, you can sign up for it, you know, for free for the first $25 US dollar. You get that credit, and I think if you're in different region, if you decide to do it, if you encounter issue, please let me know, because I can get the credit for you too. And I'll show you in a second. So Astra Streaming has managed Pulsar, and you don't need to manage all of the database yourself. You let the cloud, basically Astra, DataStax, manage it. And if you want to do things yourself, you can also use Luna Streaming. Luna is essentially Pulsar, but you manage the cloud yourself too. And if you want to purchase for enterprise support, you can do that too. And then if you want to go all the way open source, you can use the community-driven Pulsar. And basically, DataStax as this stream offering is, again, Luna Streaming and Astra Streaming. Astra, at this current time, we're still seeking for early access participants. So if you're interested too, you're welcome, and let me know. We can kind of sign you up too as an early access participants too. So. And okay, so now let me kind of I think I have about 5 minutes, right? Yeah, let me really quickly show you. Oops, this actually, let me, oops. This is a little bit the fonts, but okay, so anyway, if you go to like Astra, let me kind of, astra.datastax.com, and then this would be, you will get this. And so first time, if you come in here and you haven't signed up, you can actually do a sign up in here. But since I have already done it, so I won't go through that step. And you do not need to give your credit card. But if you want to give it, there's also an extra $200 US dollar for extra credit too. But I'll share that code with you. But otherwise too, once you have set up, you can as easily as set up, for example, I have my Google account. I can just quickly sign into here. And okay. Yeah, actually the resolution here is harder to see the whole thing. But the thing is, but just to give you an idea, right? So I already have, right, if you're here, you can create your database quite easily. This is Cassandra database, but I wanted to quickly show you too. So it will show you too, when you first start up, it will have credits remaining for you. Anybody coming in will be $25 US. And it's pretty sufficient for every month too, so that's kind of a good thing, right? So try it out. So, and then over here, you can create your database, and I've already created it, so I won't get into that part. But if you want to do Pulsar for the Astra streaming, you can do create stream in here. So create stream is basically, I talk about, you can enter your tenant name, so you can give it some name, some tenant, and then also too, the provider and region too, you can have Google Cloud, Amazon, or Microsoft Azure too. All these come to you already included in the $25 credit, so you don't need to pay, right? So which is nice, and you select your region, and okay, so that's that. And actually, because the resolution is kind of interesting here, otherwise you see the whole thing side by side. So over here, once you're good, then you can say create tenant. But since I've already created the tenant, so I won't do it, but we'll just quickly show you. For example, actually, I'm doing another thing, and you can actually have different organization to organize your different streams too. So in this particular case, I'm doing a proof of concept, so I'm just using this particular one. So I've already created my stream. Just wanted to quickly show that to you. And basically, this is nice too. If you want to kind of create the CDC, back to the CDC change data capture, you can do that from this interface. So over here, quick start, right? And once you created it, I can't actually, I don't know. This is really hard to move. Anyway, the resolution doesn't come out good, but otherwise you see the whole thing. And basically, if you click on your created stream, and then has the quick start, and it has all the guided information. How do you get started to create a topic? How do you produce data as a publisher? And how do you consume data? All of these things are listed here. And then confirm the data is flowing. For example, it gives you this guideline too, so it's kind of nice. It has getting started, kind of interactive demo, all of these links already there. So if you're interested to try it out, try the quick start, and then you can also like connect. And how do you write a Java client, for example, a publishing client? So I don't know how this, I just don't know how to make it a little smaller. Oh, I'll make it smaller. Okay, that's fine. Sorry. So yeah, so this works out better. But even though the resolution is small, so basically if you want to know how to start up with a producer client, so you can actually go to like connect over here. There's Java client or Python, all of these. So you can follow examples here. There's also consumer client too over here. And then also doing just reader to client, for example. And then over here, how do you create a topic, right? So over a topic, you should be able to also then do create topic in here too. And I've already created topic. So if you click on it, you see that there are different topics. You can create topics like persistent topic or non-persistent. If you don't care about saving things, you can do non-persistent. And then there's also partitioned and not partitioned topics too. So these are pretty nice to be guided. Now, if you are more into command line, there's also client that you can use too, but I don't have time to illustrate that today. And then there's also, over here, there's also CDC too. One of these, sorry. I think I only have like 2 minutes. So I may not have enough time to go through, but I would say that if you go over, is it settings somewhere? It's harder for me to see now, but otherwise too, if you want to do CDC, the change data capture, essentially what it helps you is that it creates the topic for you. We are kind of using Apache Pulsar, the publish, subscribe kind of mechanism to do the change data capture, because it's essentially, you can detect the changes in any kind of columns in your database, and then any kind of data that gets changed, you can also write a Pulsar function to kind of modify the data that you need, whatever you want. Then after that, then you can send the data to downstream. It's basically, it enables you to build the data pipeline, is what this CDC feature is. So again, I apologize because the fonts is small. I can't be completely showing you. But if you follow this, there are guidelines to show you that. And again, if you want to run Pulsar locally as a Docker desktop, there's also that option as well. So, okay, so that's that. And I think I probably don't have as much time, so I'll go back to the slides really quickly to give you some information of where to go from here. And please keep in touch. And these are like different links too that you can get to Pulsar. Pulsar at the apache.org site, and then Bookkeeper, Zookeeper, and then also specific for DataStax, for CDC for Astra, DB. There's also this link to kind of visit the link to kind of get information on doing change data capture. And also the Astra DB I just showed you, astra.datastax.com, and also Astra streaming and Luna streaming. And I will share this slide deck with you. This one too is basically the Astra DB I just showed you, so you can sign up for additional $200 in credit too. And you can use the code open source 200 here. You can then get more credit for doing your work. But otherwise, if you're doing small projects, even if you don't sign up for these extra credits, I'd say it's pretty enough too. And then I also, since today don't have time to demo things, actually I have my own Twitch stream. And usually I do it every Wednesday. If I don't have travel, I will be doing it Wednesday afternoon, but US Central Time. So it's 8 hours behind you. So this is my Twitch handle. Twitch site. And also we're starting to have some neighborhood. We said join us at the hood, and we have meetup groups and also the Apache Pulsar neighborhood wiki page too. And with that, I want to thank you for having sat through my talk, and I hope this has been helpful, and please keep in touch. This is my LinkedIn and Twitter, and also I have a Discord server too. So if you're interested in connecting with me, getting more information, getting anything, I really welcome you to connect with me on Discord. So yeah, so with that, thank you very much, and feel free to ask me questions anytime. Thank you. That's good? Yeah, okay.